Okay, so this video is for pre-calc. This is covering sections 9.1 through 9.3, your sequence and series quiz review for Thursday. Okay, write the expression for the nth term of the sequence, okay, and assume that n begins with 1. So they give you a list of numbers, so here's where I suggest you create a table. In the first column we put n, in the second column we put a sub n, and we try to compare. So there's 5 terms here, so 1, 2, 3, 4, 5, the actual term number with the actual number, 2 over 1, 3 over 3, 4 over 5, 5 over 7, 6 over 9. And this is simply patterns, right? So I'm looking for the a sub nth expression. So if I look at the numerators, we're comparing the n number to the a sub n number. And if I look at the numerator, 1 to 2, I grow by 1. 2 to 3, I grow by 1. 3 to 4, I grow by 1. So it looks like the numerator is going to be n plus 1. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5, so on. Okay. And now what about that bottom number? Okay. Well, I noticed that it's always odd. And I mean, this one, it's not necessarily apparent, but you have to kind of get the gist. If I skip 1, 3 is very close to 4. 5 is very close to 6. 7 is very close to 8. 9 is very close to 10. So if I take n, and this is going to be the denominator, if I take n and I times it by 2, and then I subtract 1. So let's see. 2 times 1 is 2, minus 1 is 1. 2 times 2 is 4, minus 1 is 3. 2 times 3 is 6, minus 1 is 5. 2 times 4 is 8, minus 1 is 7. 2 times 5 is 10, minus 1 is 9. That is correct. And this is your a sub nth expression. The parentheses are not necessary in your final answer. But again, this is what we're looking for. Pattern building. How does the term number compare to the actual number as the term? Okay, 2. Factorial problem. Okay, so in this factorial we're doing 2n minus 1 factorial over 2n, that's a plus 1 factorial. Okay, and if I was to attack this problem, again there's variables, so it's kind of tricky, but I would look at the smaller number first. The top number is smaller, so this is smaller. And I would list it out using the definition of a factorial. So the definition of a factorial says start with 1, times it by 2, times it by 3, dot, 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 all the way to the final number, which is 2n minus 1. Okay? And I'm going to do the same thing with the 2n plus 1. However, I'm going to be clever. Because 2n plus 1 is bigger than 2n minus 1, I need to figure out how much bigger. So if we think about 2n plus 1 as the final number, and I'll do the same thing down here. So 1 times 2 times 3 times dot, 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 times 2n plus 1. Right? What are the terms right before the 2n plus 1? Well, if I'm looking for the term right before, subtract 1 from the forward term. So to get the previous term to 2n plus 1, subtract 1, you get 2n. And to get the previous term to 2n, subtract 1, you get 2n minus 1. And these are the two previous terms before the final number, 2n plus 1. So notice how I'm going to rewrite this. The top stays the same. But the bottom, I'm going to write it with a couple extra numbers in this product. 1 times 2 times 3 times dot, 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 times 2n minus 1 times 2n times 2n plus 1. So this is the factorial, and again, this dot, dot, dot represents a whole bunch of numbers. But it really matters about the final numbers, because look, 1 cancels with 1, 2 with 2, 3 with 3. All these numbers in between cancel with all those numbers in between. The 2n minus 1 cancels with the 2n minus 1, and now your numerator is just a 1, and now your denominator is 2n times 2n plus 1. And there's no need to multiply that out if you don't want to, and that's the final answer. Okay, so again, when you're dealing with these variables, you're looking for the differences between the two factorials. Okay, so there you go. Next, 3. Find a formula for a sub n for the arithmetic sequence. Okay? So for arithmetic, I know I'm going to have to use this formula. A sub n equals a sub 1 plus n minus 1 times the common difference. And I would like to get it down to this formula, a sub n equals dn plus c. And again, it's just like by simplifying this. Okay, no big deal. So we are given non-consecutive terms. Non-consecutive terms. And this is where it's difficult. These two terms are 4 terms apart. So here's what I do. I start by finding the difference. So I'm going to take the farther one, a12 minus a8. That would be 42 minus 26. That is 16. Okay? And now that is not the common difference because there are 4 terms in between. But if there are 4 terms in between, that is 4 differences. So 4 common differences equals 16. So take 16 and divide by 4 to find what one difference is between consecutive terms. And the common difference is 4. Good. So I can plug that in for D. But now I don't have my first term. So what I'm going to use is one of these given terms in this formula to get a1. Okay? So to do that, I'm going to choose the smaller number. I'm going to choose the a sub 8. So this a sub 8 right here, this 26, is going to go in for a sub n, meaning that n is going to become 8, and I will be able to solve for a sub 1. So down here in this pink color, a sub 8, which is 26. So I'm doing this formula right here, right down there. 26 equals a sub 1 plus n is 8, because that's the n number for the term number for 26, 8 minus 1, times that common difference of 4. So this is 26 equals a sub 1. This is 7 times 4, which is 28. And if I subtract 28 on both sides, a sub 1 is negative 2. Okay? So now I can fill in this formula. So I'll come back here in orange. So a sub n equals negative 2 plus n minus 1 times 4. And I'm going to distribute the 4. A sub n equals negative 2 plus 4n minus 4. Combine the negative 2 and the negative 4 to get negative 6. So we have 4n minus 6. And there is the formula that we're looking for. Okay, so remember these non-consecutive problems. They're the toughest ones. Okay, next one. Find the partial sum. Okay, and when you see this 6n, you need to understand that that is arithmetic. Right? That is of the form dn plus c, 6n plus 0. So it's arithmetic. There's no exponents. This is linear. Right? Arithmetic means linear. Remember that idea. Okay. So there is a formula. S sub n equals n over 2 times the first term plus the last term. So n is the number of terms. So that is the number of terms between, or including 10 to 100. Well, remember, the quick way is to 100 minus 10, but then you have to add 1 for the first term. So this is 90 plus 1, that's 91. So be careful of that. So that's the number of terms, that's my n. A sub 1 is the first term. That is plugging 10 in for n, the bottom number. And a sub n is the last term. That's plugging 100 in for n. And that's 600. So now, we're going to have 91 over 2 times 60 plus 600. And I'll just type away. And this will give me the sum of those numbers in that sequence from 10 to 100. So 91 divided by 2 times 60 plus 600. And I get 30,030. or 30,300, or 30,030, I was right, 30,030. So again, what is the point? Instead of writing all those numbers down from term 10 through term 100 and adding them together, we use this quick little formula. Cool. Next, here we go, word problem. An object with negligible air resistance is dropped from a plane. During the first seconds of fall, the object falls 4.9 meters. During the second second, it falls 14.7 meters. During the third second, it falls 24.5 meters. During the fourth second, it falls 34.3 meters. If this arithmetic pattern continues, how many meters will the object fall in 10 seconds? Okay. Now, this is a total distance problem. So it's a total problem. And total should lead you to sum. So this is going to be the sum of an arithmetic sequence. Now, I'm going to list out what they give us. So what do they give us? Well, they give us the first four terms. 4.9 plus 14.7 plus 24.5 plus 34.3. And we want to find the sum all the way to a sub 10. Okay, so that's what we're looking for, right? Because this is the distance they fall in each second, so to find the total distance, you would add them all together. Okay, it's not the distance, the total distance from the beginning, it's the distance during each second. So it goes, so like a picture would be, here's my object, and as it's falling, okay, so it goes 4.9, and it's here. And then it goes 14.7, and it's here. And then it goes 24.5, and it's here. Okay, so that's the idea, is that each second it's falling a different distance. So we're looking for that total distance. All right. So the first thing I would like in this arithmetic sequence is the a sub n. Okay, and to get the a sub n, I need my a sub 1, and I need my difference. Okay, well, they give me a sub 1. A sub 1 is here, so that's good. So a sub n equals 4.9 plus n minus 1, and now I need my common difference. Well, they give you consecutive terms, so to find the common difference, take a2 minus a1. Take 14.7 minus 4.9. And what does this come out to be? This comes out to be 9.8. And there's your difference. Times 9.8. Okay, and now we're going to distribute the 9.8. So I get a sub n equals 4.8 plus 9.8n minus 9.8. I will then rewrite this by combining the 4.8 and the negative 9.8 to get 9.8n minus, I'm sorry, this is 4.9. Sorry. Let me do that better. So this is a 4.9. So 4.9 minus 9.8 is negative 4.9. So again, I just copied it down wrong. That's a 4.9. And there's my a sub n. So what I'm really looking for is I'm looking for a partial sum in this problem. So I'm looking for the sum, and I'm going to use n from n equals 1 to 10, because it's after 10 seconds, of this formula. 9.8n minus 4.9. So if I ask you right in sigma notation, this is what you're looking for. You're looking for the first term, the last term, and then that a sub n. So to find this sum, I need the number of terms divided by 2 times the first term and the last term. Well, from 1 to 10, again, 10 minus 1 is, so n, 10 minus 1 plus 1, that's 10. A sub 1 was given to me, it's 4.9, and a sub n is me plugging 10 into that formula, 9.8 times 10 minus 4.9. And 9.8 times 10 minus 4.9 is 93.1. So I'm going to take this formula over here, so the sum is equal to 10 over 2 times the first term, 4.9, plus the last term, 93.1. And that comes out to be 490. And that is the distance it fell. That's the difference it fell after 10 seconds, 490 meters. Okay. All right, good. So that's an arithmetic sequence, or arithmetic sum, right? Partial sum. Finding the a sub nth term, and then finding the actual sum using the formula. Good. Okay, 3 more here from section 9.3, geometric now. Here we go. So it says, find the nth term of the geometric sequence. Okay. And then find, so just find the nth term. Okay. So when we do this, this is the formula. A sub n equals a sub 1 r to the n minus 1. We need this. So we need a sub 1 and we need r. Okay. So we are given 2 terms, a sub 4 and a sub 7. Now again, these are non-consecutive. So this is one of those non-consecutive problems. Okay. So we're looking for a common ratio in our geometric sequence. So what I'm going to do is I'm going to take a7 over a sub 4, which is 2/3 over negative 18, and I'm going to divide this out. So I will multiply by the reciprocal. That's negative 2 over 54. Both are divisible by 2. So that ratio simplifies to negative 1 over 27. Now this is not r. This is going to be r cubed, because there are 3 terms between the 7th and the 4th term. So this is r cubed. So now we take the cube root. So r simplifies to negative 1 over, and the cube root of 27 is 3. So I have r. So if I'm looking to plug in my formula, a sub n equals, I have r. Negative 1/3. And now I'm looking for a sub 1. To find a sub 1, I do something very similar to what I did above for the arithmetic. I have a definite term, a sub 4 and a sub 7. Use one of them, plug them in. When you plug them in, again, this, I'll use a sub 4. This negative 18 goes in for a sub n. That means that 4 goes in for n, and I can solve for a 1. So negative 18 equals a sub 1 times negative 1/3 to the 4 minus 1. Again, because I'm using the 4th term. Negative 18 equals. This simplifies to, this becomes a 3. And when I cube a fraction, I cube both parts. Negative stays negative because it's cubed. 1 cubed is 1. 3 cubed is 27. So negative 127 times a 1. And to get rid of this negative 127, multiply by the reciprocal of negative 27. And when I multiply this out, it turns positive 46. So a sub 1 is 46. And that goes right up in there. And there's your formula for the nth term in this geometric sequence. And now I could find any term I wanted to in this sequence. All right. So the tricky part here with the non-consecutive is, if there's distance between your 2 terms, that is the exponent of r. Take that root to find what r is. Okay, next here, I have an infinite sum listed out. And they want to know, what is the infinite sum? Or what is the sum of this infinite series? So the first thing I'm going to do is I'm going to put it in summation notation with the sigma. Okay? So when I do this, I need a bottom number. Now, we're going to assume that that is a 1. We start with the first term. And if this is infinite, the top number is infinity. If it's a finite sum, that top number is where you stop. Okay? And now I need my a sub n. Remember, a sub n for geometric, this is geometric, is going to be, and you would be told this, is going to be a sub 1 r to the n minus 1. So I need this. Well, I do have my first term. My first term is 8. Now I need to find my r. Well, they give you consecutive terms. So to find r, I'm going to use a2 over a1. Remember, it's a ratio. 6 over 8, and that is 3/4, or 0.75. It does not matter to me. And then your exponent is n minus 1. There we go. And now that we have this notation, now we can use the infinite sum formula. Now the infinite sum formula is S equals the first term over 1 minus r. Now I need to know what the first term is. Now again, the first term is by plugging in that bottom number into the expression. 8 times 3/4 to the 1 minus 1. Well, 1 minus 1 makes an exponent of 0, which makes this 3/4 become a 1. So your a sub 1 is just 8. And your r is the ratio, and of course we found that, that's 3/4. It's the base of the exponent, okay? So when I do this sum, and I'll change it to blue, when I do this sum, it's simply going to be 8 divided by 1 minus 3/4. And if you use a calculator, just make sure you put this in parentheses. I believe the 3/4 will need its own parenthesis too. So we'll do 8 divided by parenthesis, 1 minus parenthesis, 3 divided by 4. Close the 3/4, close the denominator, and I get an answer of 32. So again, if you were to look at this infinite sum and just keep adding terms and terms and terms, you would be approaching this number of 32. Okay. Alright, last problem here. Okay, salary problem. Now we did a problem in class with the annuity. This is like the annuity problem. So if you're looking for a similarity, this is similar to annuity problem. Similar to annuity. Okay. All right, here's what it says. It says an investments firm has a job opening with a salary of $30,000 for the first year. Suppose that during the next 39 years, there is a 5% raise each year. Find the total compensation over the 40-year period. Okay. Now I would give you this formula. It's going to say use this. And this is a simple growth formula. A equals P 1 plus R to the t power. There is no compoundings. You're just getting the raise each year. So in this problem, you start with the starting salary. So the starting salary is $30,000. But then you get this raise of 5%. So the R is 0.05. And you're doing this over a 40-year period. Okay? All right. Now there is one. So we want to sum this up because we don't just want the salary that year. We want the combined salary for the 40-year period. So this is going to be a sum problem. So we are going to use a sum. Okay, and I'm going to start with year 1, and I'm going to go through the 40 years. Okay. Now this is going to go into the sum equation, the summation. So 30,000. Times 1 plus 0. So what is 1? 1 plus 0.5. This is just 1.05. So 1.05. And now the exponent is the tricky part. Okay? You're plugging in numbers for the exponent. Now, because of the way this is worded and the way that bonuses work, bonuses are given at the end of the year. Okay? So notice it says here, during the next 39 years you get the bonus. So that first year you don't get the bonus. So in this problem, your exponent has to be n minus 1. If it was n, you would get the bonus for all 40 years. But when you take away 1, you're taking away 1 year for the bonus. Okay, so I hope that kind of makes sense. Again, so the n minus 1 is because you don't want to count the first year. The first year is just the salary, not the salary and the bonus. You don't get a bonus your first year. You get a bonus after your first year. Okay, and now this is a finite geometric sum. So we're going to sum it up using the formula S sub n equals, and this one's more the messy one, the first term times 1 minus r to the n over 1 minus r. So I need 3 things. A sub 1. And you get this by plugging in 1 into your expression. 30,000 times 1.05 to the 1 minus 1. And that 1 minus 1 is 0, making that 1.05 go away, and your A sub 1 is just 30,000. And again, that should make sense. The first term should just be the salary, not the salary with the increase. Okay. Next, your R is going to be the number, the base of the exponent, 1.05. And your n is your number of compoundings. And again, we're going 1 to 40. That's 40. 40 minus 1 is 39. Add 1 is 40. So now I plug this into my formula. So my A sub 1 is 30,000. 1 minus 1.05 to the n is 40. All over 1 minus 1.05. Now what I would do if you're going to do it all at once is I would put the top in a parenthesis. I'd put the bottom in a parenthesis. And if this was a fraction or a negative number, the 1.05 to the 40 should be in a parenthesis. So let's just practice that by putting it in a parenthesis. So I will speak it as I do it. Hopefully you're doing it with us. Okay? So what do? 30,000, parenthesis for the big fraction, parenthesis for the numerator, 1 minus, parenthesis for the 1.05, 1.05. Close the parenthesis for the 1.05. Raise it to the 40, and then close the parenthesis for the numerator. So my numerator is done. Divided by, open a parenthesis for the denominator, 1 minus 1.05. Close the denominator's parenthesis, and close the big fraction parenthesis. And you press enter, and you get the big number. This number is 36. 23993.23. And that would be dollars. And that would be how much you make over those 40 years. So this is in the millions, which makes sense. I mean, if you make tens of thousands of dollars per year, times that by 40 years, you should make close to some millions. Now again, each year you're not making 30,000, you're making 30,000 plus this raise of 5%. So that's sort of where the summation comes into play. So again, just be careful. I'll circle this exponent. Just be very careful. N minus 1 means I do not count the first year, versus the annuity where the exponent was just the n. Okay? So I'll try to give you a hint on the quiz. Just do your best. All right, so thanks for watching. Hopefully this all made sense, and we'll see you on Thursday.